Much all unit long when we've had these rational functions, what have we done first? Close your computers, give me your attention up here. When we have these rational functions, what have we done first? Anybody? Good. Factor. All right. Factor both the numerator and the denominator, and just put your pencil down when you're ready. If you're struggling, you can look up here for a hint. Okay, so I noticed that the numerator had a GCF of 3, so I was left with x squared minus 9. I observed that x squared plus 9 was a difference of 2 squares and could be factored thusly. I factored the denominator as x minus 1, x plus 2. Give me a thumbs up if you got all of that. Great. Now, once we factored, what is the very next thing? I mean, if factoring is 1a, this thing is 1b. Something about the denominator. Good. We want to set the denominator equal to 0. Because we cannot divide by 0. Places the denominator equal to... I should set the whole thing equal to 0, but it's going to leave me with setting each part individually equal to 0 because it's a product. It would suffice for you to, you know, in terms of saving time on your test, if you just... Guys, if you just said, hey, if you went right from x minus 1 and you arrowed down and said x equal 1 and right from x plus 2 to saying that x equal negative 2, totally fine with that in terms of time saving. I think we are to that point that we understand that. Are you with me? These are excluded values. Why are they excluded? Very good. They also will often be vertical asymptotes. Unless there's a like factor in the top, then they will be what? Very good. Okay. And since we have no like factors in the top, they are going to be vertical asymptotes. Excluded values and vertical asymptotes in this case. Excluded from the domain, we mean to say, specifically. Okay. The domain, although this one's not asking us for it, would be all reals except 1 and negative 2. Any questions? All right. Now we're going to find the intercepts. Find x and y ints. We know x-intercepts are some x value where y is 0. We know y-intercepts are some y value where the x was 0. So let me find my y-ints. Y-ints. Again, I'm just going to substitute 0 in place of y, and I'm going to 0 in place of x and find that associated y. I'm going to use my factored form. F of x is equal to 3 open parentheses x plus 3, x minus 3. Yeah. Factored denominator form is x minus 1, x plus 2. Let's every place I see an x, let's substitute a 0. Do that and put your pencil down when you're ready. I got 13.5. Did anybody else get that? 27 over 2. Okay. If you didn't quite finish, I'm sorry for the, just in terms of the, we won't get to enough of them going kind of fast. Forgive me. We're saying that y is 13.5. We're saying f of 0 is 13.5. That's same as the point 0, 13.5. Any questions? Okay. Nothing new there. We've done that. Accents. I'm going to let y be 0 and I'm going to solve for x. Again, my original function. What is it? X minus 1, x plus 2. I'm doing 3 instead of 9. This time I'm letting y be 0, that whole object. Okay. I'm not going to recopy all this mess for a second. Just know that it should go down here. If the whole fraction is equal to 0, what is really equal to 0? The numerator. So I can reduce this statement into setting the numerator equal to 0. It's not the, we know the bottom can't ever be 0. If a fraction is 0, it's the top that is 0. Is everybody all right with that? If the fraction is equal to 0, really what we mean is the top is 0. And again, we have a product. We can set each one of these factors equal to 0. Well, you can't set 3 equal to 0. It's constant. If we set x minus 3 equal to 0, what's the associated factor? 0. Good. If we set x plus 3 equal to 0, what's the associated? These are the x-intercepts, 3 and negative 3. Okay? All right, now we're going to sketch the graph. We did not do this in the example problem. I anticipate you having one problem on the test that I'm going to ask you to sketch the graph. It was in the assignment. We just didn't do any examples. He did, however, show a couple of examples in the videos. The person that does the videos. Here I go. I'm going to sketch the graph now. I'm going to count by 4s in my y direction because what was that y-intercept? It was like 13.5. Okay, counting by 4s this way. I'm going to count by 1s in this way. Can totally do that. Perfectly legal. I'm going to start by plotting all of the asymptotes. What were my asymptotes again? 1 and -2. Those were the vertical asymptotes, right? Those are the walls. Those are going to be the breaks in the graph. That means the graph is going to come in 3 parts since we have 2 walls. Come on. Expletive. Insert expletive here. One more time. What are they? 1. I'm going to draw a vertical line at 1. X equal 1. And -2. And I'm going to draw a vertical line at -2. These are fundamental parts of the graph. What you're going to find is you're going to have a part that's to the left of -2. You're going to have a part that's in between these two. And you're going to have a part that's over here to the right. Okay. What is our horizontal asymptote here? There was 3 conditions for our horizontal asymptote. It had to do with the degree of the top and the bottom. It is going to be 3. Did you say that, Natalie? How do you know? Oh my gosh, you said that better than I could have. If the degree is equal, we look at the ratio. Makes me a little tear. Well done, young lady. You look at the ratio, the fraction that is the leading coefficient. It's 3/1. Okay, so that's 3. What's interesting about a horizontal asymptote is the graph can cross it early. It's what it tends to. So we're counting by 4s here. My horizontal asymptote would occur a little bit underneath 4. Are y'all with me? That is the line y equals 3. Now let's plot our points that we know for sure. I want black, but I want thinner black. Is that black? That looks black. We had a y-int at 13.5, yeah? We had x-ints at 3 and -3. Plot all those jokers. Plot an x-intercept at 3. Plot a x-intercept at -3. And plot a y-int at 13.5. Count by 4s. 13.5 would be slightly underneath the middle, wouldn't it? And again, I'm not sweating you getting exactly right. If you've properly identified it over here, you know, then I can assume that you're going to get that right. Any questions? All right, guys. This is what we didn't discuss during class, but was in the videos. You're gonna have a piece over here, and it's gonna be asymptotic to the wall and asymptotic to that line on the right. It's gonna be asymptotic on the left to the wall and asymptotic to the line in the middle. In between these two, it's gonna be asymptotic. It's gonna be like an S curve. It's gonna hit the asymptote in the middle. How do you know which way it's going to be? How do I know? Is it going to be under here or is it going to be on top? How do I know that? You have to consider values close to the walls and at the infinities. Okay, I'm going to work with this middle portion, and you'll see what I'm driving at. All right. Where did you go? If all that disappeared, that's going to be vexing. There it is. Okay. let's think about this fraction as I get very close to this. What is this value here? What is this? 1, 2, 3, 4, 5, 6. Okay. Here's what we're trying to do right now. I'm trying to figure out how it's going to behave over here on the right hand side. Y'all with me? Consider this line x equal 1. And let's start putting in values that are that are approaching 1 from this side. Like 2, 1, but more specifically like 1.1, 1.01, 1.001, as we're getting super close to 1, but not quite 1. Are y'all with me? I'm saying as we approach an x value of 1, we're just substituting x values very close to 1 into this thing, and we're going to see what happens. Here's what we know. As it gets close to this line, it's going to be an asymptote, y'all. All we're trying to see, is it going to be going really high, or is it going to be going really negative? Are y'all with me? It's going to look like this, or it's going to look like this. We just want to know, is it going to be really negative close to the line here, or is it going to be... We're going to find out. We're going to see. All right? Imagine a number very close to 1, like 1.01. What is the sign of this thing going to be if we're very close to 1? But above 1. Positive. Is everybody with me? Okay. What is the sign of this thing going to be? If we're putting in, imagine putting in 1.01. In x plus 2, if I substitute 1.01, what is the sign? Is everybody okay with that? Right here, if I substitute 1.01, what's the sign going to be? Right here, if I substitute 1.01, what's the sign going to be? Negative. Can all you knuckleheads do what we just did? What's a positive times a positive? What's a negative times a positive? What's a negative divided by a positive? Negative. We are going to go to negative infinity over here. Okay? So that means it's going to flatten out over here. Gosh, you're a stone cold genius. Beautiful job, Natalie. Good catch. That is alertness. If I had if you were a seal, I would throw you a fish right now. Man, gosh, that just really makes me happy. Y'all paying close enough attention to catch the teacher's mistakes. Might be a genius. Any questions? How is it getting to be super negative? Here's why. When you put numbers in, imagine right here. If you put numbers in very close to 1, like 1.000000001, you're going to get this thing to be super small, aren't you? And then this thing over here is going to be like 3, isn't it? Because it's going to be 1 and a little bit plus 2 is 3. So if you get something super small times 3, you're going to get something super small. And if you take any number and divide by something super small, you get super big. Are y'all with me? Okay. That's why it looks like this in the middle. Now, we're going to decide how it's going to look over here. in between. Do the same deal. Imagine getting close to 1, but below 1. Holden only is doing this one. Here's what we're doing, Holden. We're figuring out how this thing behaves. This is called local behavior. All right? We're figuring out how it behaves close to these asymptotes. So here's what we're doing, Holden. We're in the middle here. Are you with me? We're imagining getting very close to the wall, our electrified fence here, but not touching it. So we're talking about numbers like 0.9, 0.99, 0.999. Okay? Imagine putting a number very close to 1 but below 1. And I'm going to look at each one of these factors. Just tell me positive or negative. If I put a number very close to 1 but less than 1, what's this going to produce? Is everybody okay with that? What's this one going to produce? Everybody okay with that? What's this one going to produce? Very good. Everybody okay with that? What's this one going to produce? You're a genius, Holden. Is everybody okay with all that? Yeah, we did slightly above 1. Slightly above 1. Okay? So now we have a negative times a positive. What's that product? Here we have negative times a positive. What's that product? What is the quotient of a negative divided negative? So, as we approach 1 from the left, this joker is going to be positive without bound. It's going to look like this. I did it again, didn't I, Natalie? Missed the dang point. It has to go through this. And probably over here it's going to be going down. All right? But I'm going to do this one. I'm getting in the middle, it can hit the horizontal asymptote. The horizontal asymptotes are at the infinities. In the middle, the horizontal asymptote is free to hit. All right? I'm going to consider what's happening to the left here. I'm talking about numbers approaching -2, but slightly less than -2. Like -1 point whatever. Putting in -1.9, this would be negative. Putting in -1.9, this would be positive. Putting in -1.9, this would be positive. Putting in -1.9, this would be negative. So it's the same, isn't it? It's a negative divided negative. That's a positive. So it's also approaching. So we get this. I was wrong about that other side. We get a parabola-esque behavior there in the middle. So this one won't cross the horizontal asymptote, but it could. We're going to check this in a second by graphing to make sure we're right, okay? I'm a human. Say it again. How did it change to moving upwards? Okay, because let's examine the signs again. I might have made a mistake. What was this x value of this asymptote, Natalie? This one. This one was 1. This one was what? Okay, we're considering, we're approaching this line. So the x values approaching this line would be like -1.9, -1.99, -1.999. Slightly greater than, I should say slightly greater than -2. Slightly to the right of -2. So here, -1.9 would produce a negative, wouldn't it? Here, -1.9 would produce a positive. A very small positive. That's what's going to give the asymptotic behavior. Here, it would give positive, and here it would give negative. So we end up with a negative divided negative. We end up with positive again. It's yes, -1.9. If I put in -1.9, this would be a negative minus a negative is going to be a negative. Here, -1.9 plus 3 would be like 1.
I was mishearing the negative part. So
yeah, gotcha. Is everybody okay with it's going to be, I think it's going to be parabolic-like in between. Okay? All right, now I'm looking at this left-hand side. Now we're approaching -2 from the right, from the left. So we're talking about like -2.01. Here I go. -2.01 would still be a negative here, wouldn't it? But here, -2.01 would be negative. Here, -2.01 would still be positive, and here it would be negative. So what's a negative times a negative? And what's a negative divided by positive? Negative. So getting close to my line here, we're tending towards negative infinity. Good catch. I made that mistake on purpose. No, I didn't. And it's going to be asymptotic to that line. All right, I'm going to try graphing this on Desmos, and hopefully we get the same picture. If not, I'll have to give a refund on my math degree.